So this video is going to continue with our concept of properties of logarithms. More specifically, we're just going to do some practice problems, kind of talk through them a little bit. I'm also going to show you that change of base formula that we talked about. So I'm going to start with that one. So we had our change of base formula if I had log base a of x, and we said that was equal to log base whatever I pick of x over log base whatever I picked of a. And if you remember, I used the concept that a is the base, and so a is in the basement or the denominator. So let's think about why that actually works for us now that we know a little bit more about our properties of logs. So I'm going to start with log base a of x equals, we're going to go with y. Okay, and I would like to solve for y. So the first thing, to get rid of our log, I can use an exponential equals a to the y. Because of my properties of logs, those are going to cancel, and I get x equals a to the y. Okay, well, that's all well and good, except that doesn't really help us because now I just have y up in my exponent. But if I want to get something down out of the exponent, I can introduce a logarithm, and that could be a log base whatever I pick. So I'm going to pick base b. So b could be 10, could be e, could be a, could be w, could be 3, could be 7, who knows. But using this concept, I can then use my properties of logs, and this y is going to swing down in front. So to solve for y, I'm going to divide by, because this is multiplication now, so to undo multiplication, I'm going to divide. And y is equal to log base b of x over log base b of a. Well, here's y, but y was also up here, which means that log base a of x could replace this y, in which case we get our change of base formula. So there's really no need to memorize your change of base. You can actually just go through and solve every time, and you'll get to your correct solution. Now, I know there's no place to really write that down on your notes, and I apologize, but if you want to, you can write it up in the kind of space above, so you have it back to reference. All right, so expand the expression. We're going to use our properties of logs. So I see some multiplication going on here, which I know can be rewritten using addition. So log 4 of x plus log 4 of y to the 6th plus log 4 of z to the 4th. Then, because of log properties, I can swing these exponents down. So I'm going to end up with log 4 of x plus 6, log 4 of y plus 4, log 4 of z. And there will be my expanded expression. All right, for this next one, log base 7 of the square root of x squared divided by y to the 3rd. First thing I'm going to do here is I'm going to apply my exponent rule and just kind of rewrite this so that I have a power. And that power is going to be to the 1/2 because of this square root. Well, now that I have this 1/2, I can use my power property and bring that down in front. Well, now I see division. So I'm going to get log of x squared minus log of y to the 3rd. And now I can use that power property again. Oops, tried to change colors, didn't let me. There we go. And I end up with 1/2 times 2 log of x minus 3 log of y. Now I think this is a perfectly okay expanded answer. You've gotten rid of all of the properties that you could have with your logarithms, but you also could then distribute. This 1/2 times 2 is going to cancel itself out, and then 1/2 times negative 3 is going to be negative, I already had a negative sign, negative 3 over 2 log y, and I would say that either one of these answers is going to be sufficient. All right, next one. I'm going to have you try on your own, so go ahead and pause your video, think about your log properties, and then come back and we'll see if we match. So using our log properties, I chose to split first with the subtraction. Then I rewrote this square root as a 1/2 power, and then using the power property, I swung that 1/2 down in front, and this is going to be my final answer. Now, some students might try to do something with this addition here, but if you remember from our properties of logs, we don't have a sum property. We have a product property that turns into addition, but if we start with addition, there's no way really for us to break that up using our properties of logarithms. All right, these next three then are going to be condense the expression, and I'm going to add those same directions I did before, which is into a single logarithm, which means you should not write the word log or ln, if you're talking about natural log, more than once in your final answer. It should just be the natural log or the log of one quantity. So working backwards here, I'm going to use my power property. I'm going to bring that square up. Then I'm going to notice my addition could be condensed down into multiplication. And that's going to be my final answer because I've written one single logarithm. Here, I've got some powers I can move. So this is going to be the natural log of x to the third plus the natural log of y squared minus the natural log of z to the fourth. Well, now I've got addition here. So I know that that can be changed into multiplication. Then I still have this minus z to the fourth. Well, now hopefully you recognize that subtraction can be written as division. But again, I can only write this ln once. So x to the third times y to the second is all going to be divided by z to the fourth. But you only write natural log once, single logarithm. All right, this next one, oops, there we go. I can start by cleaning up the inside, or I could start by distributing in the 2. Either one is going to work. So I'm going to start by cleaning up the inside and just let this 2 kind of hang out in front, and I'm going to come back to it later. So I'm going to divide first. I get the natural log of x over x plus 1, and then I still have minus the natural log of x minus 1. Okay, so this 2 is still just hanging out. Now I have division again. Well, if I have a fraction being divided by something, that's the same thing as that fraction being multiplied by the reciprocal. So really I just get a over b times c. So in my case, what that's leading us to is my a value over my b value times my c value. I left too much space there. Okay, so my division, that's going to end up being in the denominator. So then this 2, with this power property, I can swing this back up to the top. So the natural log of x over x plus 1 times x minus 1 all squared. So there's one method. Another method is to distribute this 2 before you even start. So this is a separate way. We could go 2 natural log of x minus 2 natural log of x plus 1 minus 2 natural log of x minus 1, in which case each one of these individually, you can apply this power property. So the natural log of x squared minus the natural log of x plus 1 squared minus the natural log of x minus 1 squared, because this square is going to go to each one of those terms. So that would be another way to do it. The last way I want to suggest is thinking about this negative and this negative. Before you ever start, you can factor out that negative. If you take a negative out of a negative, you're left with this positive. So now this part, order of operations would say should be done first. So now we only have to worry about one division problem and knowing that our denominator is supposed to be that whole thing. Ooh, and I just made a connection. This right here is, you could FOIL that together. You could end up with x squared minus 1 in the bottom with an x. I think that might be a little oversimplified, but either one would work, and it's great if you recognize it. Obviously, it took me a second. All right, so then the last thing, question for understanding, describe in your own words how the properties of logs relate to the properties of exponents. You might want to refer to your chart that you had before. And the very last thing, I just want to show you this change of base thing one more time. So if I start with log base a of x equals y, I can start by raising both sides to the a power, right? Rewriting as an exponential. Then I can pick any base. I'm going to pick the natural log this time. Then I can use log properties. Then I can use division. So what ended as y could be replaced up here. And so I get log base a of x is equal to my new y. And notice that that would have been true if I did the natural log, if I did the common log, or if I did any base that I picked. All right, so not a formula you need to memorize. Understand the math and how it works.